Good morning once again. In the previous class, we have discussed about the exit status of any command. This exit status will be returned after the execution of any command, and that you can check with this dollar question mark. If you print the content of that with the echo command, echo dollar question mark, then you can directly get what is the exit status of the last command, whether it is successful, whether it is a failure, or any other case. That is what the exit status. The exit status means you have to remember this dollar question mark. Then we have started discussing this logical operators. You can write multiple commands, and if you want to see the output of both the commands or any one of the command, you can use this operator in the command itself, right? Like this grep command, some pattern, then file name, the operator, logical and operator. Once again, the another command echo, the pattern found. It is going to find that content and then it will print this. If it is an or, if it is not found, pattern not found. Any one of them is going to execute. The same way $1 positional parameters with the command line arguments also you can use this or operator, logical or operator. Then we have discussed this if statements. We have seen these if statements in so many languages, C, C++, Java, or any other programming languages. The same thing. If here in the case of the expression, here you have to write the command. If that results in true, then the next set of statements will execute. If you write the opposite of if fi, it indicates the complete if is been closed. It is just only if there is another case called if else. If the command what you write here, if it is successful, then the set of statements what you write inside that it is going to execute. Else, if this fails, if this command fails, then next set of statements. Once again, fi indicates the if statement is closed. Or else multiple conditions are there. If, else if, any number of else if, last one else. Once again, fi at the end. And I have demonstrated one single example. If followed by one command, and I don't want the output of this command, that is why I want just only the exit status. I want just the status, but I don't want the output of this command. That is why I redirect the output to the dummy.txt. If this is successful, if this command execution is successful, then it will execute this command, pattern found, or else the next statement, echo pattern not found. Once again, small fi I have to write. Fi, it indicates complete if statement is closed. Next, we have started with this test statements. See, what is the limitation with the if statements are? If statements, here you have to write the commands. It is not going to evaluate any expression here. Here you have to write the command in order to compare the two numbers, or to compare the two strings, or to check the file permissions, whether it has a read permission, write permission, or any other permissions. In that case, it is not possible with the if statements. That is why we go for this test statement. Test statements work for three cases: to compare the numbers, to compare the string, or a single number with a null value, whether it contains the null, or to check the file attributes. These are the key, the operators that you have to remember: double equals, or hyphen eq, or a single hyphen ne, not equal, not equal, greater than or equal to, less than or equal to. These are the operators that in between you have to use. We'll see this. We'll open the terminal, we'll clear it. X equals 5 semicolon, y equals 6, z equals once again 5. Now, if you check the content of that x, if you check like this, it is not going to print. If you check like this, it is not going to print. If you want to check the content of that echo $x, then it will print the content of that, whether exactly x contains 5 or any other value. I have cleared the screen, but I want to check whether x and z are same. For that, test, then what is the first value? $x hyphen eq hyphen $y. There is no output of this command, but how to check what is the previous status of the last command, exit status? That if you check, you are going to get what is the result of that. It is equal to 1. That 1 indicates they are not equal. X and Z, whether they are equal, we already know they are equal. That is why the answer is 0. If it is matches, then the exit status is the success. The success indicates 0. If it is a failure, then it will be indicated by 1. And still there are more than 1, that is 2, 3, 4, 5. Those numbers are being indicates the different types of failures. But in this case, we are interested only in 0 and 1. In that way, just replace the EQ with the other operators, whether they are not equal. How to check? Yes, not equal. They are equal. That is why the previous status it is 1. It's a failure. Since they are equal, if they are equal, it should give it as 0. If I indicates it as not equal, it will give it as 1. In the same way, you replace this to test the other operators, replace this hyphen EQ, hyphen NE with so many operators, this greater than or equal to, less than or equal to. You can directly replace and check the output. Instead of running it 2 times, I have added semicolon, then echo $? In a single command itself, you can see the output also. See, greater than or equal to semicolon echo $? In the single statement, if you run, you will get the answer. 0 indicates yes, it is greater than or equal to. It is equal to, it matches, that is why it is 0. Whether it is less than or equal to the same command, equal to, it matches. If it is less than, if you check, it gives you 1. That is the meaning, and this is how you are going to use the test statements. Test statements will be used like this. If you want to add it, just add the semicolon at the end and then add the another command. The next thing is, other than the test statements, here is there one example that the test statements are there in the if condition. For that, I have one example here. Say I have one example, the test example. In this program, what it contains is, in the if the condition place, we have one test $hyphen. hash. What it indicates, it stores the number of arguments, command line arguments that I have passed. If that is equal to 0, it gives a usage pattern file, some number, the passive. Else if, see here there is another way of representation. See this test statements, if if you don't like this way, there is another way with this brackets, rectangular brackets, you can execute. That is another way. You can just directly replace test with the angular brackets, the big brackets. But what is the main thing here is, after this brackets, you have to leave one space. And before the closing brackets, you have to leave one space. You have to note, make a note, this one. After this brackets, you have to give one space. Before you close the brackets, you give one space. Then you can directly replace the word test with this brackets itself. The same thing, instead of test, I have included the brackets here. If the number of arguments, if it is equal to 2, if it is equal to 2, then grep command, whatever I enter, the $1, enter $1, the first argument, the second argument, first argument will be pattern, second argument will be file. It is going to search. If it fails, echo, this is not found in the particular file. Pattern is not found in this file. If it succeeds, you will get the output. If the number of arguments, if it is not 2, you did not enter 2 arguments is the output. We'll see the output now. Control L, I have cleared the thing. SH test example. See now, I don't enter any arguments. Usage test example dot s pattern. This one, the $0 will give you the file name. $0 will give you the file name. The first if is matched. Now I'll enter one argument, echo or ECH. I will echo only. I'll search. You did not enter 2 arguments. This is the output because the number of arguments is 1. Now I'll enter 2 arguments. The pattern is echo. The second I'll give it as some file name, sample shell.sh. I have a file in that particular folder. That is why I'm giving that file, echo sample shell.sh. Now it is able to give the output of that. Which file it is this one, sample shell. This file, in this file, at 4 lines echo statements are there, and it has given this output. I think this is clear. Even what I am going to demonstrate here is, in after the if, you have to write the command. If that is successful, it will execute the set of statements. Here just the output, echo output, you can redirect to the one file also. Inside the devices, there will be a file. Inside that file, even you can write to that. That is what we have demonstrated with this redirection operator. This output will be redirected to the file and also to the terminal. Two things. This else if is another else. And this is the output. If you don't give any arguments, just it will match the first if you give the 2 arguments, then grep command will start running. RAM, it will be the pattern, the file name will be the DAM. That is why RAM is not found in DAM. Another case, DSC. DSC is not found in sample shell because the first this is not executed. That is why R operator will come into picture here. The second part is going to execute. The $1 is not found in the $2. $1 is DSC, $2 is fine. Carefully you have to observe, then only you can understand this. If you miss any topic, you have to do some homework multiple times. You have to read and then you can understand these things. It is not only to compare the numbers, it is not only to compare the numbers, we use uh, the test statements. Even for the string comparison, you can use it. How to use it for string? It is like this. The first string equals second string. First string not equal to is the operator, second string. In order to check whether it is not a null string, -n. Whether it is a null string, -z string. This STG means the string is assigned and not null, and it is a double equals is there. The double equals, if we use, that works in corn and bash shell. We'll see one example about the string, how it works. String compare. See, there is one example, one if, another else. Okay. Instead of the test statements, I have included the brackets. $hash, it includes the number of command line arguments. How many I pass? 5, 6, 2, 3, that number. If that is equal to 0, then what the logic is, I'll enter the string to be searched. If I don't give any argument, I am making the program interactive, that's all. We'll see here itself. SH, what is the file name? String compare the example.sh. Now I have not passed any command line argument. Then the $hash, what it includes? Directly it indicates 0. 0 equals 0, it enters if. If I pass any command line arguments, then directly it will go to the else, another file, the test example.sh, that we are going to run. Enter the string to be searched. Now, here there is a read statement in the program. Read means then it is an interactive. You can take the input. Enter the string to be searched. Now the string which I am going to search is, once again I use the same file echo or the calendar. I use the word calendar. CAL I want to search. If I don't enter calendar, what happens? I just press enter. You have not entered the string. It will print this message. You have not entered the string and I want to terminate it. Should not continue. That is why exit 1. If I pass exit 1, this function, directly it will terminate the program. See this -z, what it indicates? I have shown the -z here, whether string is a null string. I have not entered anything means that indicates it is a null string. -z is the p name what I have entered this, it is a null string. Then this condition is satisfied. That is why it is going to print this message, you have not entered the string. -z is whether this value, what the user entered, whether it is a null value. Now, assume that I have entered the value itself, the string, which one? Calendar. Pattern I have entered. Enter the file name to be used. This one I am not going to enter. You have not entered the file name. How it has matched? See here. Echo, enter the file name to be used. Enter the file name to be used. Read file name. I have not entered anything. Then file name contains null. See here, once again, within the brackets, it is equal to the test itself. exclamatory hyphen n, the file name. See, hyphen n means whether it is not a null string. Exclamatory hyphen n means once again it is checking whether it is a null value. It is just 2 times negation. Instead of these two, you can directly write hyphen z. The negation of hyphen n is hyphen z. The opposite of hyphen z is hyphen n. Instead of writing hyphen z, what we have written is exclamatory hyphen n we have written. That indicates you are going to negate the meaning of this hyphen n, that is hyphen z. It is going to check whether this is a null value once again. If you remove this exclamatory marks, then it indicates if it is not a null value, then only this condition will be satisfied. This command will execute. Here you have included the exclamatory mark. That is why it is going to negate the hyphen n. That then it is going to check whether file name is a null string. Yes, it is a null string. That is why you have not entered the file name. Now what I do is I'll enter the file name. Calendar. The file name is test example, not test example, sample shell dot sh. In 3 lines, calendar is there. Here CAL is there. In the second line, CAL is there. In the third line, CAL is there. In this file, in 3 lines, calendar is there. CAL, CAL, CAL. That is why you have seen the output. You may get the doubt where that logic is there, the grep command in this. What we have did is the previous example directly we are running in from the program itself. From the program, we are going to run the file. See here, sh, file name, pattern, then the file name. This input is been passed to this file, command line arguments. This matches with the number of arguments are 2, then the grep command will execute, and that is what you have seen the output there. I have directly executed this file, the another file from the one more file, the source file. See the else part. Directly I execute the another file from this program. This $hash that indicates all the command line, all the arguments that will be directly passed here itself. You can do the same thing, calendar, CAL, then the file name sample shell dot sh. If I execute like this, the same output you are going to get. In this case, it will not go inside this if, it will directly come to else. Directly it will execute this file, test example.sh, this file. Here the $$ will be replaced with the number of arguments what I pass. Then it is going to print the output. That is how the string comparison can be done. This hyphen z to check whether it is a null, hyphen n whether it is not a null, exclamatory includes it is going to negate it. In that way you can compare the string. Or else you can directly use this equal symbol, string 1 equals string 2. One more, the test statements we use it for files to check the file attribute, whether it has a read permission, write permission, execute permission, whether it is a directory, whether it is a link, all those things that you can check with this the test statements. How is, we'll see with an example, the file example.sh. Say I have used the command line arguments, the $1. The $1 will be the first argument. I'll run the file sh file example. The first parameter I'll give is this file example.sh will be $0. The next one will be the $1 what I enter. In that variable it is going to store sample. I'll give test example dot for the first file, the test example.sh. Everyone, please send your attendance. If you have forgot, please send your attendance. Okay, I'll give the file name. This is what the file name that will be checked in all the if statements. See here, the file is both readable and writable. How to check that whether it is giving correctly or not? ls-l test example.sh. If you see here, read permission is there and also write permission is there. R and W. R and W is there. How it works is negation of -e. See, this -e means whether that file exists or not. That we are going to check. If you give -f, whether it is a device file, regular file, or a directory file. If it is a directory file, it is -d. If it is a normal text file, regular file, -f. If that file exists and it is readable, read permission is there -r, write permission W, executable permission X. If it is a directory D, the file exists but size is greater than 0. It is not empty. Then that in order to check that -s. In the same way, another 3 to 4 are there, whether the older or newer, it is just going to check the L file, whether it is a link file or not. It is going to check the uh, what the last modification time, whether it is older or newer. All those things, this -nt, -ot, whether this F1 is linked to F2, because multiple files built in, they have been linked. Within that, we have just demonstrated two, -e to check whether it exists or not. -r, whether it has read permission, whether it has write permission. We'll give a file which does not exist. Test example 1.sh. Cannot access test example.sh. No such file or directory. Okay. It is for test example 1.sh. File does not exist. If you give that, it is going to match here itself. It is negation of -e. Negation of -e means if you use -e, then it will check for whether it exists. Negation means does not exist. Then this if condition is satisfied, it will come inside. Negation, the exclamatory mark means negate. Here, if in order to check the other attributes, you can directly replace this -w with X, or I'll check for the executable permission, whether the executable permission is there for that file. Test example. File is not writable. File not writable. Test example.sh. Okay, I have to change it to executable. File not executable. That you have seen with the ls command. There were no execute permission. X is not there. See here. That is why it is giving the message that file not executable. As similar to the in the C language, here you have the case. Till now we have discussed exit if statements, then the test statements with the brackets, and then the test statements that we used for to compare the numbers, compare the string, and to check the file attributes. Now we are coming for case statements. Case is nothing but the switch case, what you have seen in the C, the same switch case, how exactly we are going to use in the shell script, and also what are the some limitations that we should know. Okay, how to use this case statements are, the case statements will be like this. You write the expression here. Expression is, it is your user expression. The user enters in, it should match the pattern 1 or pattern 2 or pattern 3. If it matches this, the next set of commands it is going to execute this one. Any number of patterns you can write. Finally, you have to write the reverse of case, ESAC, that indicates case statement is closed. One example I will show now, case example. See the case example, there is one program. The menu have written, the first one is the list of files, ls command, second process, third one date command, fourth one number of users, the fifth one quit. The user will enter its choice. That will be stored in the variable read. This is the expression now, what the user has entered. If that should match this pattern, number 1, 2, 3, 4, 5. If the user enters 1, then I'll see the list of files. The last echo statement will be the invalid option. If I don't enter anything, that is going to match to the star, that is invalid option. Finally, ESAC. Now I'll run this sh case example. I want to see the number of process 2. If I enter 2, oh sorry, it is not a command line argument. Directly the read statement is there. I'll enter now 2. I can see the list of processes. If I enter, my choice is in this menu 3. The 3 is will be date. It is going to give me the date. If my choice is 4, who are all the users? Root is the user. It has executed this command. If my choice is 5, it is the option is exit function. It is going to close. If my choice is any other number, invalid option, it is going to match this star, invalid option. This case statements, whatever the expression you write here, it is going to match this pattern and it is going to execute the statements. That is how it works, the case. The case is not going to handle the relation or the file test, but for string it is going to match. Instead of 1, 2, 3, there you can use these strings, Monday, Tuesday, Wednesday, any, there you can use string. It can also handles numbers and strings. How it is going to match for the multiple patterns, that we'll discuss in the next class. If you have sent the attendance, you can exit. If you have any doubts, you can contact, you can ask the doubt in the WhatsApp or through the call.